The location theorem states if f of x is a polynomial function with terms in descending degrees of the variable, such that f of a and f of b have opposite signs, then there is at least one real zero between a and b. Okay, so this is actually a common sense theorem, but maybe when you read it, you're not really sure what's going on. So some things that you got to remember here is f of x or f of a or f of b are referring to the y value when you plug in an x. So a and b are just two random x values that you may want to plug into the polynomial function. Now you'd be doing that because, again, what we're trying to do here is solve for the zeros of the polynomial function. So you'd be plugging in values, or better yet, you'd be using the rational zero theorem, doing synthetic division to see if the number you chose is a zero. And sometimes you'd have a whole bunch to choose from, and so you're kind of randomly just picking things and plugging them in. So when you're doing this with synthetic division, if you notice that one of the values you pick is a positive, and then the next value you pick is a negative, for example, then somewhere in between those two values of x that you've chosen, the polynomial had to cross the x-axis and therefore hit a zero. Okay, so this doesn't actually solve it for you, but it could narrow down your choices. And we're going to look at an example of that here in a second. Here is a graph of a cubic polynomial function. And I want to start with reiterating what's going on when you're talking about f of a or f of b. Okay, so if we look at, let's just start with f of 0, you can actually come up, or at least with an estimate of the y value, because what you're saying here is that this statement says what is y when x is 0. So you go across until you get to x being 0 here at the origin, and then you would go up or down until you find the curve. Okay, and you can see right there that the y value would be 8. Okay, and so if you moved along to something else and said, well, what is f of 1? You'd come over to x is 1, and you'd follow it up or down until you find the curve, and you'd see that it would be 9. Okay, and every x value imaginable will produce some kind of y value. Now, if you're looking at the way this curve goes, it gets really steep. And so, f of 5 looks like about between 12 and 13 there somewhere. But if you got all the way to f of 10, it's way, way up there. Okay? So again, this theorem is talking about when you pick random values of x and plug them in, what's going on with the y values. Okay? So for instance, like the two that we just chose here, 0 and 1, they both produce positive y values. They're both up here somewhere. Okay, so there's no way to, you're never going to cross the x-axis with both positives. Okay, so there is no 0 in between, no 0 for the polynomial function between 0 and 1. Now again, you're not completely randomly choosing these x values, because you're going to think of the rational zero theorem to kind of narrow down your choices. So, for instance, let's just say that one of your choices was f of -1. Okay, and so you would do synthetic division and see what the remainder was. And it would give you, we can kind of follow it on this curve, down, maybe it's -4 to -5. I know it's kind of hard to say there. We'll just call it -4.5. Okay, and this is the location theorem, perfectly described, right? At -1, we're down here at a negative value somewhere. Then when we get to 0, we jump up to a positive value. So somewhere in between there, this curve has to cross the x-axis, and therefore there's a 0 sitting in there somewhere. Okay, and likewise, if we pick 2, and then we got to 3, right? At 2, we're up here at positive. At 3, we're down here at negative. So in between x is 2 and x is 3, we had to cross the y value. So it's very important to understand what's going on here. So again, that theorem is saying if you pick an a and plug it in, or do synthetic division with it, and you get a value back, and then you pick another number to plug in, b, and then you get a value back that has the opposite sign, in between those two numbers, it's going to cross the x-axis at least once. Maybe it crosses 2 or 3 times, who knows? Okay, but at least once, and therefore there's at least one real 0 in between those two numbers. Now again, this is just helping us narrow down our search for our zeros. And that's the whole point of this theorem.